Welcome to Satellite Communication. This is Dr. Ali Mugebel, and we're introducing the course on satellite communication. The focus would be on the communication part, but we'll need to have some basics about space and satellites. The agenda for the following first part of the course is to cover the meaning of satellites, defining satellites, different types of orbits, geostationary Earth orbit, low Earth orbit, medium Earth orbit, and high Earth orbit. And then we'll look at the history in the second video, followed by the spectrum allocation for satellite applications and communication. And then we'll look at the major applications where satellites are used, communication, navigation. That would be followed by the major ITU, Intelsat, Inmarsat, and some terminologies, some sources of information, and we'll conclude with some of the current developments and future trends. Introduction. So what are satellites? We can define satellites according to the following. We can say satellites are: a satellite is a moon, planet, or a machine that orbits a planet or a star. And of course, you can debate this definition, but I just got this definition from NASA. So if you want the exact link, then this is how we define a satellite according to NASA. You could have different ways of looking at satellite, but it's basically a moon, a planet or machine that orbits a planet or another star. To motivate the topics, let's understand how much is the total satellite revenue. Before we proceed with satellites, their type and so on, we need to know, is it really worth it to talk about satellites and communication? I'm showing the following figure, which is shows the years 2010 to 2020. It shows the revenue in billions of US dollars. And it's divided according to the application, whether it's TV, mobile application, Earth observation, what have you. So we can see that the most revenue is for TV broadcasting, digital broadcasting satellite. And the source of this information, if you want to, I'm sharing the link here, if you want to get more about the exact distribution. So just to give you an idea that we're speaking about hundreds of billions of US dollars per year. Now, how many satellites are there? Is it 10, 20, 30, 100? The number of satellites, I leave this answer for you to get exact answer from the web, as it's really dynamic number and changing. But we're speaking about tens of thousands of satellites, or at least around 10,000 satellites. And this picture shows you, if you would like to kind of exaggerate the satellite size, you'll find that the Earth is occupied with thousands, let's say, rather than thousands of satellites that are active, and maybe more than 10,000 of satellites that are active or already not active, passive. What do we mean by space? Because once we talk about satellites, we need to get some idea about some orbiting mechanism, and we'll take some introduction into that. So in addition to our communication skills, we need to have some basics about aerospace, orbital mechanism, and so on. So we're not going to go deep. If you want exact definitions and about the aerospace part, maybe you can find another course. Our focus is on communication, but of course we need to know the basics of satellites and their different types. In the next slide, I'll be focusing in the orbit, which means the orbital where and how the satellite rotates around the Earth. We have two basic types. One is called the geostationary satellite orbit. It's stationary because the satellite rotates with the Earth. So if there is a satellite here, let's say in the projected on Saudi Arabia, then it's going to rotate with Saudi Arabia as the Earth rotates. It will be facing the same country, same location, same, and this is where we use our satellite dishes at the roof of the houses. We don't need to change the direction because they are pointing towards a geostationary satellite. So they are moving with the Earth in the same mechanism, and that's why we don't need to adjust the antenna. This is called geostationary satellite orbit. That requires a certain height or distance from the Earth. Other types include non-geostationary satellite orbit, which are moving around the Earth and then they are not synchronized to the rotation of the Earth. This is called geostationary, and we have GSO and NGSO, non-geostationary. Again, inside non-geostationary, we'll have different types as we're going to see. Before we move to the next slide and speak about the satellite orbits in more details, explain them, this picture just shows you the different levels of the space from the Earth, from 6 to 20 kilometers, 50 kilometers, 85 and 690 and so on. And it shows you where you expect to have balloons, airplanes, and the different terminologies, names for this part of the space, whether it's called troposphere, stratosphere, and what have you. So according to the distance, we expect to have a different application. Now, this picture shows you the geostationary Earth orbit and the other orbits, which I will explain in more details in the coming slides. The geostationary Earth orbit. Geostationary Earth orbit. This is the diagram of the Earth, and it shows you that you expect to have a geostationary Earth orbit around distance from the Earth, which is about 36,000 kilometers. That's a long distance. What is so special about these orbits? They appear to be stationary over a fixed point on the ground. So the projection of the satellite on Earth will be rotating with the Earth exactly. It can establish 1/3 of the Earth's surface, which means we need 3 of them to cover the entire Earth. It can establish 1/3 of the Earth's surface. We can cover entire continent with one satellite, 24/7 operations, because they are pointing to the same location on Earth. Direct broadcast satellite television, or in short DBS TV, has the largest single revenue for this type of satellites. They're usually used for TV. And we are speaking of about 17 billion in 1998, and now it's about 88.4 billion in about 2020. And you can find more recent data, but this is the order of increase in these 22 years. In 2001, there was about 200 geostationary Earth orbits, which are in orbit, with satellite spacing between them is almost 2 degrees. So if this is a circle, you'll find that the satellites are close to each other, and in every 2 degrees you'll find 2 to 3 degrees there will be an operating satellite in almost all available frequency bands. And as of May 2021, the website, you see satellite database, I'm sharing the link with you. He is speaking about 4,550 known satellites, geostationary Earth orbit, and this is really a large number. Geostationary Earth orbit improved in weight, size, lifetime, and cost over the years. There is big improvement and change. Example of these, a geostationary Earth orbit can weigh about 6,000 kilometers, 6 tons, and will cost about $125 million. Of course, these numbers are dynamic, they change with time. Just I'm giving you an idea, with lifetime of about 15 years. So you can guess now how much should be the yearly income of these satellites. If 15 years is the lifetime and this is the total cost, you can divide these numbers and get the expected cost per year, and of course the income is expected to be more than that to make some profit. Typical path length from Earth is about, we said from here, this is the altitude, is about 35.786 thousand kilometers, or about 36. These are close numbers. And of course, because it covers not just the direct path, there is slant path, we can have also a distance of up to 38.5 thousand kilometers because of the tilted distance. Now compare, this is just a side question, since our focus on satellite communication, compare that with fiber optics. And why don't we use just fiber optics? What's the advantage of satellite over fiber optics, and when do we use which? Just to give you a hint about the answer, there are islands in Indonesia, which is made of 3,000 islands over more than 1,000 miles of distance. So would you choose to cover them with fiber optics? and the answer is left for you. Types of non-geostationary satellite orbits, NGOS. Recall that we have geostationary Earth orbit or geostationary Earth satellite orbit. So we can say GSO when it stands for geostationary satellite orbit, or geostationary Earth orbit if you're speaking about the orbit itself. We are done with this. Now we focus on non-geostationary. There are three types. Okay, so I'm coloring them here. So we have low Earth orbit. Okay, and then we have medium Earth orbit, and then we have highly elliptical orbit shown in red here. Okay, so for the low Earth orbit, in 2000, low Earth orbit, as the name suggests, it's very low, it's close to the Earth. There was about 138 satellites. By 2022, there are more than 2,000 of these. And the programs that are SpaceX and other programs you heard of, we'll speak about them later. They are dealing with low Earth, providing internet to the entire Earth. So you need low Earth orbit to be close to reduce the latency. In addition to data services, LEO satellites are used for Earth imaging because it's easier to take an image, and surveillance. The second type is the medium Earth orbit. The medium Earth orbit shown in green here. It's medium between geostationary Earth and low Earth orbit. And an example of this is the popular global satellites, global positioning system, the GPS, which uses 24 medium Earth orbit satellites. Application for medium Earth include positioning application, and which is increasing dramatically. So GPS was the American system. Other system, GLONASS and other European and Russian systems are also there, Galileo. The last type is the highly elliptical orbit. Highly elliptical orbit. This is elliptical. Okay, it takes the shape of an ellipse. So sometimes it's close to the Earth, sometimes it's not. And an example of this is the Russian Molniya highly elliptical orbit. And it was the first regional satellite that covered the Earth in this way. So this is elliptical orbit. So we have low, medium, and geostationary. And we have the highly elliptical orbit. Okay, so this is highly elliptical orbit. What we're going to do in the next videos, we will be covering the history of satellite communication, and then we'll look at other interesting applications and so on. Once we are done with the introduction, we'll move into other chapters, including the dynamics of satellites and what is so special about satellite communication. So keep with us. We'll see you in the coming video. Thank you very much for being good listeners.